Hey everyone, it's Laz from Adatis, and today we'll be going through the very important topic of modeling our Power BI model as closely as possible to a star schema approach. So, I previously had a 3-part video series all on Power BI performance tips, which you can watch through the link up here, where star schemas were briefly discussed, but I find this to be a very important thing that we should always promote, so I decided to make a dedicated video to this subject, right? Now, to showcase this, we will start off with some slides just to understand the basics of data modeling, the importance of a star schema, and then we're going to jump into an AdventureWorks model where we will be transforming a flat table into a star schema together. So, with that said, let's go ahead and check this out. Let's start off with the very basics and answer the question, what is a data model? Now, quite simply, data modeling is an approach which is used to connect multiple tables together through the use of relationships, right? And by creating a relationship between tables, Power BI connects them and knows how the data propagates, so travels from one table to the other table. And this means we can create reports from different columns of different tables, right? So that is all a data model is. No need to confuse it anymore. And as you can see on screen, these are various tables we require in our Power BI solution from an AdventureWorks database, and we simply create relationships between them. So now that we understand that a data model is simply a set of tables that are connected together using relationships, we should understand the approach to follow when creating a data model in Power BI. So when modeling our data in Power BI, it's recommended that we use something known as a star schema approach. And as we can see from the diagram on the screen, all this means is we should have one central table known as the fact table that contains only numerical columns and foreign keys. Also, we should have tables surrounding the central table known as dimensions that contain only descriptive columns and primary keys, okay? Now, the reason for modeling our data like this is to ensure, well, firstly, higher performance, right? We have less tables and we have less relationships between those tables. Therefore, it increases the overall retrieval time, right? That's what it should be doing. Also, we have less repeated data in our tables when going with a star schema approach. Apart from that, it's more scalable, so it's easy to add additional dimensions, columns, measures in the future, rather than, let's say, having one large flat table. Also, it's more capability enabled. So what do I mean by this? It allows us to use the full features of Power BI, such as drill down, drill through, and many other things without any issues arising. And then, more importantly, right, the reason for using a star schema is due to keeping everything simple, right? It's easy to read, understand, and use in various ways, such as writing DAX, right? It really does simplify everything. So to reiterate, a star schema promotes less tables and less relationships. Therefore, it brings all elements closer together, naturally resulting to faster queries response. Okay. So let's now highlight the components of a star schema. So we first have our fact table that contains the numerical columns that we want to measure, such as our sales and our revenue. And our fact table, like we saw earlier, is in the center of our data model. And the fact table allows us to answer the what questions, such as what are my sales? What is my revenue? We then have our dimension tables that contain descriptive columns that we want to view our measures by. So again, our dimension tables surround our fact table and they allow us to answer the by questions, such as what are my sales by territory? What is my revenue by time period? And then we have our relationships, which simply join the fact table, which is in the center, to all the dimension tables, which are surrounding the fact table. And some things worth calling out: a dimension table contains a ID column which uniquely identifies each row, right? This is known as the primary key, and the fact table also contains an ID column, but this is used simply to reference back to the dimension table and is known as a foreign key as well. And we will be exploring these concepts through the demo later on, as we will be deriving a primary key, foreign key for all the tables that we will be ingesting from AdventureWorks as well. Okay. So now that we understand what a star schema is and the component, let's see how it all comes together. So the first thing you can see on my screen are some tables from AdventureWorks, which we will be using, right? So the reason we call it a star schema is due to the physical model resembling a star shape, with the fact table, so sales in this case, being in the center, and then all the dimension tables surrounding it representing almost the star points. So these are then all brought together with relationships through the keys. And this is what we should all try and do with our Power BI models. Okay. Now, to finish up on the slides, many may just ask, well, why can we not simply import a large flat file into Power BI with all columns in a single table, right? Let's just keep it simple. We don't need to think about primary keys, foreign keys, relationships, star schemas, nothing. Well, we can use a single flat table, as we can see on screen, and you know what? This will work. However, as data volumes start to grow, it will affect performance as everything is repeated. Apart from that, it's harder to maintain and add additional data that we may need for analysis at a separate period. And also it can restrict us from a capability such as drill down or drill through as well. So for this reason, we should split our data into facts and dimensions and join them all using relationships, as we can see on the screen. Now we separated that flat table out into these facts and dimensions. So enough of these slides. Let's now go ahead and see this in action as well. So we are in our Power BI solution where we have a flat table of data coming from AdventureWorks, but do keep in mind, of course, I just put this together myself and purposely set it up to demo how to approach this, okay? But anyway, this is a common scenario, right, where users give the requirements for some data, which is then provided as a flat table and of course is then used for reporting purposes. And like we said earlier in the slides, this works, okay? So having a flat table, as you can see on screen, with loads of columns that was provided to us, we can go ahead and create a report. For example, if I go back into the report tab, into our canvas, I can simply say, well, I want to see sales amount. So I'm going to drag sales amount on there. We'll make that as a stacked column chart for now. And let's say we want to view it by, or break it up by sales territory group in the legend. And then also, let's say we just want to view it by model name on the axes for whatever reason. There you go. So the point we're making here, again, is as we can see, the flat table still gives us the results that we need. However, notice how frustrating it can be for users if they had to scroll up and down without no actual structure in a long list of columns, right? Not ideal. In addition to this, if we look at our table, so we jump in here, and you can notice that we have sales territory country, sales territory group, product name, and various other columns as well. And again, notice that the same text value is being repeated many times, right? So what we want is to take this and make it into, or align it as closely as possible to a star schema approach. And again, this is to get all those benefits that we mentioned earlier through the slides, such as better performance, making the solution more scalable, enabling more capabilities, right? And of course, just making everything a tad simpler as well, okay? So let's start this off, and the way to do that is we have to go to Power Query, and to do that, I'm going to select Transform Data in the home ribbon up there. And notice now we have our sales data query here. So that's just our single table. Again, it's just a query I put together, combining various different data from an AdventureWorks database, right? And we need to separate this out into facts and dimensions. So the way I usually like to approach this, it is quite a common approach. Select the sales data, of course, and then afterwards select choose columns. That way you have a display of all the columns available in this query. Now, of course, you can just simply scroll left and right, but I just find it a lot simpler to select choose columns instead, right? And this is essentially where you would usually start from, right? So even though you may need to do a bit more investigation in regards to the solutions you're working on for understanding, well, what columns should be grouped into what dimensions and fact tables, right? I essentially just made it a tad easier for us now. So all the columns that we're going to be using, everything from order quantity all the way down to ship date will be for our sales fact table. Everything from first name down to commute distance will be for the customer dimension. Then we have, of course, these three columns here. So sales territory region to sales territory group. This will be the territory dimension. And then everything below from product name all the way to the end will, of course, be our product dimension as well. Okay, so in other words, we will have one fact table and 3 dimensions. So the first thing we now need to do, that we understood how to group our columns into facts and dimensions, we need to duplicate the sales data because we're going to be reusing this. Okay, so I'm going to right click, duplicate, keep duplicating it, and there we have it. So the first one, we're just going to rename it now into sales fact. The second one will be our product dimension. The third one will be territory dimension. And then, of course, the last one we're going to have will be our customer dimension as well. Okay. Another thing worth pointing out, of course, when we're creating a solution to share with the business, we won't be using or adding dimension or fact in the naming convention. I'm only using this just to showcase which of our tables that we're going to be putting together are dimensions versus facts as well. Okay, so now that we have that, let's start with our first dimension, which is product dimension. Okay, so we are going to select all the columns relating to product. So let's go ahead and find those. Like we said before, we went to choose columns, and you could do it through here as well. So you can simply unselect everything and then go to all the ones in product, which are from product name, and you can select them one by one like this as well. Or what you could do, you could simply scroll. Now that we know which columns we want to keep, you can go to product name and all the way to the end. We know all these relate to the product dimension. So what I'm going to do now, I'm going to right click and select remove other columns, right? So in other words, we've just kept all the columns relating to product. And there we have it. We now have only the columns relating to product, which we also see if we select removed other columns over here. Essentially, you can see all the columns unchecked apart from the ones relating to product as well. Now you're probably thinking, great, we have our dimension, but we still have some more steps here. And of course, this is a copy of the sales data query, right? And we will have the same product name essentially repeated multiple times. So just to make that a bit more clear, if I go to product name and I'm just going to select sort ascending for a moment, there you go. So we can see that we have essentially the same product name repeated multiple times. Okay. But of course, this should not be the case for our product dimension. As we mentioned earlier, each row should represent a single product, or in this instance, it should represent a single product. Okay. So let's first select product name, or in fact, actually, let me just remove sorted rows. We don't need that anymore. But anyway, now we want to make this unique. So I'm going to select product name. I'm going to right click and then go ahead and select remove duplicates. Okay. And there we have it. Each row now represents a single product. Now, the next thing we need to do as well is to derive a primary key, which is a numerical ID, essentially, which represents each one of these products, okay? And the purpose of this is to be able to establish a relationship from our product dimension, which we're deriving now, back to the sales fact table, okay? And now, even though you may be thinking, well, we can simply just connect product name, so you can see here we have product name in our product dimension, to the product name in the sales fact table. There you have it, right? And you're right, this can be done and it will work, but we do want to avoid this, right? As we don't want text values repeated in our fact table, as you know, we will have over here due to the way, and this is due to the way essentially compression works in Power BI. Now, for more details, I will have a link on the top here where you can check out a previous video on how we should use integers before strings. Also, I would highly suggest the book, The Definitive Guide to DAX, which explains how compression works in Power BI really, really well. Okay. Anyway, to derive a primary key, we will go back to our product dimension, and whilst we're in our product dimension, we're going to select the add column up here in the ribbon. And then once we've selected add column, let's now go ahead and select index column. But I'm going to select the drop down and say I want to start from 1. Okay, there we go. And what's happened? Well, Power BI has now added an index column. So essentially it numbers all the products that we want, right? So each product has been assigned a unique number against it now. And one thing I'd always recommend is for us to rename it now. So I'm going to call this product ID. So this is our primary key for the product dimension. And then once we rename it, I always say the best thing to do as well is to essentially change the position of it. So I'm going to right click and I'm going to say move to beginning. And it's always nice to have your primary keys and foreign keys at the beginning of a table rather than at the end or the middle. It's just a lot more easier to understand as well. Okay, so notice now we have our primary key. So in other words, Mountain 100 Silver 38 is represented by 1, Mountain 200 Silver 38 is represented by 2, Fender Set Mountain is represented by 3, etc, etc, etc. Okay, and as we have the primary key, this is what we will now use to establish a relationship to the sales fact table. But notice, of course, we don't have the product ID. So the one that we just derived here does not exist in the sales fact. Okay, so let's go ahead and bring it over into the sales fact. So the way we're going to do that, I select the sales fact, select the home ribbon, and then in the home ribbon, let's go ahead and select merge queries. So what happens here, it tells us at the top, select the table and matching columns to create a merged table. So all we're doing here is we're taking the product ID from the product dimension and bringing it back to the sales fact. That way we can establish a relationship. So we want to merge sales fact to product dimension. And now that we are in here, we need to select the common field, right? And of course, this will be based off the product name. So let's find product name in the first one. There we have it. And then product name from the second one. And by the way, everyone, this is the reason why I haven't yet deleted the columns relating to product from the sales table, because we still need them for this step, right? But anyway, so the common field between the two tables is product name. The join kind will be left outer. That's absolutely fine. We'll leave it as a default. We want everything from the first table and everything matching from the second one as well. So with that said, let's now go ahead and click OK. And notice we now have an additional column added at the end of the sales fact. Product dimension, so it just gives the name of the table we merged to, and we're now going to select the sort of two-sided arrow here, and here is where we select the columns we want to merge to the sales fact from the product dimension. So of course the only thing that we want in here is product ID. I'm going to uncheck use original column name as prefix, no need for that there. And there we have it. And like we said before, just to finish this off, we're going to right click product ID and we're going to do move to beginning, and now we have our foreign key, product ID, in our fact table as well. Okay, so the final thing we need to do is essentially go ahead and, well, delete all columns relating to product from sales fact, right? We no longer need them. So to do that, I can simply scroll across and find the same ones. So we have product name, and I know it's all the way to the end. I'm going to right click. This time, rather than say remove other columns, we want to remove these selected columns. So just select remove columns, and there you have it. So we still have the sales fact table. The only difference now is all the columns relating to product have been removed from here because we've added them into their own dimension, and we've derived a primary key in here which uniquely identifies every product, and we also brought back this product ID into the fact table. That way we can establish a relationship between these two tables. Okay, now let's actually go ahead and see what happens in the model. So I'm going to click close and apply, but I'm also going to just select or remove enable load for these two because we haven't carried out the tasks on these two dimensions. So I'm going to click close and apply now. We don't want these to load. And once this finishes loading, so you can see product dimensions being loaded, the sales fact is being loaded as well. This will break, of course, now because some of the columns that we were using here that were in sales fact have been taken out from here and moved to product dimension. But we're going to go to our model, and there you have it. Notice we now have sales fact as we did and product dimension, and all we have to do now is establish a relationship from the product ID to the product ID, right? So it will be a one-to-many relationship, and that's exactly what we want, and hence the reason we removed the duplicates from the product dimension. So you can see by the little arrow here, the data propagates, so it travels from the product dimension down to the fact table. So anything the user selects in the product dimension or filters from here, it will flow down to where all our numerical attributes are, or our measures in the sales fact table as well. Okay, so that there is our first dimension. So let's go ahead and continue by going back into transform data, and we're going to derive an additional dimension, which of course this time will be our territory dimension. So I'm just going to re-enable the load there because we do of course want to load this into the model. So again, what we're going to do first, we're going to remove the other columns from here apart from the three relating to territory. Okay, so this time I'm going to select choose columns. I'm going to unselect everything. I know for territory we need sales territory region, we need sales territory country, and we need sales territory group as well. So I'm going to go ahead and click OK. And there we have it. We now have only the three columns relating to territory. Apart from that, we also, again, want to remove the duplicates. And of course, to do that, I'm going to right click on sales territory region, remove duplicates, and there we have it. As we did before, we also want to derive a primary key in here. Again, yes, we can essentially just do it between sales territory region here and in the fact table, but of course, like we said, due to compression, we'd rather use integers over strings. Okay, so to do that, again, we're going to go to add column, index column from 1. We're going to rename this here to territory ID. I'm going to right click on that, move to the beginning. So now we can see Australia is represented by 1, Northwest is represented by 2, Southwest is represented by 3, so on and so on. Okay. Now that we have this here, we go back into our sales fact, and of course we want to derive our sales territory ID in here. Okay, so we need to merge queries based on the sales territory region. So once again, we're going to select merge queries. We're going to merge with the territory dimension, and it's going to be based off, or the common field between these two tables is the sales territory region. There we go, sales territory region, and we've got sales territory region. So we're on the left outer, again, leave it as a default, click OK. And then of course we want to expand over here and say we only want to return back territory ID. Click OK there as well. And there you have it. So we're just going to move it to the beginning as well. So we now have our second foreign key, which we're going to be using to establish a relationship with the territory dimension, which has territory ID primary key in here as well. Okay, so the last thing we need to do, as always, any other columns relating to territory in our fact table now are redundant, really, because we've taken them to the territory dimension, and of course we don't want them to be hanging around in here. So to do that, we can simply scroll across and find them again. There they are, sales territory region, country and group. Right click, we're going to remove these columns, and there we have it. And once again, we're now going to go ahead and click close and apply. And we should now see an additional dimension for territory. So here's our territory dimension. The last step, of course, is to establish the relationship. So we have territory ID, and then we scroll in our sales fact, territory ID as well. So it's a one-to-many relationship. Again, one-to-many. So anything that the users of this model will be filtering from territory dimension, it will flow downwards to our sales fact. And that's exactly what we want. Okay, so there we have it. And now let's finish up with the customer dimension. So as you can imagine, we're going to select transform data once again. There we go. In customer dimension, I'm just going to enable the load, because this time we do want to load it into the actual model itself, right? And what we want here, we want to remove all columns apart from the ones, like we said before, that are between first name and commute distance, which are the ones last in the list. So, oops, sorry, no, product is last on the list. So as you can see, this is why sometimes scrolling left and right can be confusing. So we select choose columns instead, unselect everything, and then of course first name all the way down to commute distance. So these are all columns relating to customer. So we're going to go ahead and click OK. Now, something worth calling out here, in the previous dimensions, I just simply right-clicked on a single column and said remove duplicates, right? Now, I can do this also for customer by first name, right? But of course, as you can imagine, many customers will have the same first name and possibly even the same last name as well. So it's even possible that the customer may have the same first name, last name, and even the same date of birth. So for this reason, I'm going to go ahead and remove duplicates by email, right? Because I know for this particular data set, every customer is indeed uniquely identified by an email address, and there is no blank or missing data. Nothing is null in this data set. But of course, when working with your data set, this is something that you will need to decide. Maybe what you should do is do it by first name, last name, birthday, and email address in order to bring back the unique customer. But again, for now, I'm just going to select email address, right click, and remove duplicates. Okay. And now I know that every row represents a single customer. So now that we have that, we're of course going to once again add a primary key for the customer. So we're going to go to add column, index column from 1. We're going to call this customer ID. As always, we want to go ahead and move this to the beginning of our table, right? And now that we have that, we need to derive the customer ID back into our sales fact, of course, so we are able to establish a relationship as we did with all the other dimensions in the fact table as well. So I have sales fact selected. I'm now going to go to home, merge queries, and of course we're merging with customer, and this will be based off email address. So there's the email address, and also we have email address here. But again, just to call out everyone, if we did have multiple columns here that make up in order to uniquely identify a customer on each row, Power BI does give us the option almost to create a sort of composite key. So if I select first name, whilst holding down the control button, I can select a last name. I can then select date of birth and email address. And notice that what Power BI has done here is helpful because it shows us by numbering the columns in the order we selected them as well. Okay, so if this was the case here, I would also do the same for here. So first name, last name, date of birth, email address, and then click OK. Yeah. But anyway, what we did here, we just selected email address. So I'm going to unselect everything and just use email address in this instance for the common field between these two tables. So I'm going to go ahead and click OK now. We're now going to bring back, of course, our customer ID. Right click on customer ID. As always, let's move it to the beginning, and there you have it. And this is why I like moving it to the beginning of the table, why this is promoted. It's just nice to understand essentially where this table is now linking back to. So you can easily understand, well, it relates to customer, it relates to territory, it relates to product as well. Okay, so now that we have that, we can simply go ahead and click on close and apply. So let's do that. So here is our customer dimension, and notice it's created a relationship between these two tables. And this is something I'm glad this happened, because this is something you should always be aware of. Sometimes Power BI establishes a relationship between two tables if it finds matching columns, and by that I mean through the naming convention, right? So if I double click on that, we know that it should not be based off email address, but instead it should be based off the customer ID. So if I look for customer ID, there we have it, and customer ID here, click OK, and that's exactly what we are looking for, right? That's how we take a flat file that was possibly provided to us by the data team, the BI team, IT, and align it as closely as possible to a star schema to get all those benefits that we previously spoke about. Now, one thing I forgot to do, maybe you noticed, is when we was creating the customer dimension and we derived the primary key into the sales fact table in here, I forgot to remove all the columns relating to customer, right? So right now, our sales fact has all the customer dimensions, as you can see, gender, household and flag, last name, both in the fact, and then also we have the exact same details across in our customer dimension. So this should not be the case. So we go back into transform data. I'm going to go to our sales fact, and what we want to have in here are only numerical columns, right? And by that we mean we want to have foreign keys that relate back to our dimensions, as we have customer ID, territory ID, product ID, and then also all the numerical attributes which will be used to create our measures as well. So if I scroll across to the right, I'm going to go to first name all the way down to commute distance, and we'll select remove columns as well, and there we have it. So apart from the two dates that you can see here on the right hand side, if I scroll across to the left, everything else should be numerical, and that's exactly what we want from our fact table. So I'm going to go ahead and click close and apply now, and notice how much our sales fact table has essentially shrunk from a height perspective, right? We have a lot less columns in here because we moved them out as well. So from a user perspective, it's a lot easier for them to find what they are looking for as well. Now there are two additional things I just would like to show. So the first is we may have the case where the user who requested this data initially goes back to IT, the data team, BI, and requests some additional data such as product category, right? So they went ahead and said, well, I don't really want to view product information, but I want to group it by the relevant product category. And they were then provided with an additional file, which is this Excel workbook here. So I'm going to go ahead and open that just so we can have a preview of it as well. And you'll notice that it's fairly straightforward. We simply have 4 rows in here with product category key and then the description beside that. So I'm going to select transform data. And then we're going to rename product sheet 1, to product category. We're going to call this product category. And we are now going to simply go ahead and click close and apply, right? Because we was told, well, product category has the product category key. And when we provided the flat table previously under product dimension, we also gave product category key, okay? So what we could do is essentially establish a relationship between these two tables. So there we have it. Can join these two here together. And the reason I'm calling this out is this will work again, right? But the purpose of this video is to show how we align as closely as possible to a star schema approach. And what we now have here is what is known as a snowflake schema instead. So we should try and prevent having relationships between dimension tables. Again, with our star schema, we want to have less tables, less joins, right? So ideally, what I will do in this situation here, I will essentially take the column which we need, which is product category, and then merge it into product dimension instead, rather than have this additional dimension that is related to product dimension. So again, to do that, we're going to go back into transform data, select the product dimension, and we're going to say we want to merge with our product category. And we don't have to worry about deriving any additional keys this time because, of course, it's been provided for us. The join kind, we're going to leave left outer as we did before. And then, of course, we just need to expand and say, well, we need product category backed. There we have it, product category. Just going to rename this. And then, of course, what you could do, you could also go ahead and remove product category key from here since we won't be needing it anymore. But of course, for now, I'm just going to leave it there. But then one last thing we should do, product category, even though we're using it to derive the product category description in this dimension, it's no longer needed to be loaded in the actual model itself, right? So I'm going to right click and I'm going to uncheck enable load. And we do get this warning message here. I did speak about this in the previous video, so if you want any more details, be sure to check that out. But for now, I'm going to say continue. And if I now go ahead and click close and apply, as soon as that finishes loading, what we should see is the product category disappears, right? There we have it. So product category is gone. And then also at the same time, we have product category now appearing in the actual dimension table itself. Also, let's not forget, every model requires a calendar dimension. Now, it is recommended that you ask your organization as they may already have a calendar dimension. But if you don't, this can be derived simply in Power Query or maybe using some DAX as we will be doing now as well. So I'm going to select the data tab. I'm going to select new table because we want our calendar dimension. Now, we could go ahead and use something known as calendar auto, right? And as it suggests, it returns a table with one column of dates calculated from the model automatically. But I'm not going to use this now because I will need to do some additional cleaning there to keep only the dates that we need. So to save time, I'm just going to go ahead and use calendar and manually enter the min date and the max date that I need. So 2011 1st of the 1st and the between 2014 December 31st as well. And there we have it. So Power BI now gave us a single column 1st of January 2011 and 31st December 2014, because I know for this data set, those are the dates that I need. And of course, we could go ahead and derive some additional, oops, not a table. We could go ahead and derive some additional columns in here as well to use for slicing and dicing. So I can say I want the month number. So we can just do simply month and then select the date that we just derived. And then of course we might say, well, we want an additional column for maybe the month name, right? So we can do month name, and for that we'll do a format. So we want the month number in here. And there you have it. So now that we have our calendar dimension, but again, I just want to call out the way I did this here is just to showcase how we can bring a dimension, how it interlinks to our star schema. Ideally, do ask your data team, BI team, IT, or the relevant team to provide you with the calendar, or otherwise use Calendar Auto to sort of make this a bit more automated as well. But anyway, here is our calendar dimension. So now that I have that, I have my date. I can simply establish a relationship between date and order date. And there we have it, our one to many. And of course, I can also establish a relationship with due date and then also ship date. And notice that these here are inactive. I can make another video on that if this will be useful. There is various content out there. So we can use a DAX function essentially called use relationship to activate these if needed. Otherwise, we could create 3 separate dimension tables, one for order, one for due date, one for ship date. But of course, this all depends on what you're trying to achieve and how you want to display your data on your report as well. So that's everything for today's video, and we should now be aware of the importance of using a star schema, why we should try and stay away from a single table, and more importantly, how we align our model as closely as possible to a star schema using Power BI. Now, if you have any questions, do feel free to drop a comment or reach out. Take care for now.